Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMathInstruction. Today we're starting a new unit. We're going to be doing unit number 11, lesson number 1, on rotations and angle terminology. And before we even get into it, let me just kind of give you a little bit of foreshadowing on the unit. This entire unit is going to be dealing with functions that are based on the geometry of a circle and on the geometry of rotating and angles. All right, so it's very important as we first start to dig into rotations and terminology with angles and things like that, that you really master those before we actually get into what's known as the trigonometric or circular functions. All right, so you might not find it very difficult, but piece by piece, this becomes a more and more complicated type of function. So let's jump right into some angles and their terminology. All right. Now, we're going to be working a lot with angles, rotations, and where the what's called terminal ray of the angle lies. So the first thing we want to be comfortable with is that when we have an x and a y axes, they divide physical space up into what are known as 4 quadrants. Quadrant 1 is where everything is positive, both the x and the y coordinate. And then the other 3 quadrants, get kind of traced out in a counterclockwise direction. I once had a student say, all right, I know where quadrant 1 is, and then if I put my pencil down and I draw a big C, right, then the C ends up tracing out where all the other quadrants are. So quadrant 1, quadrant 2, quadrant 3, quadrant 4, and yeah, they're typically shown in Roman numerals. So we got to kind of live with that. Now let's talk a little bit about angle terminology. The first thing I want to talk about is when an angle is drawn in standard position, because you can have angles. Let me get rid of the green here. You can have angles drawn all over the place, right? These are good examples of angles. But an angle drawn in standard position has its vertex at the origin and its initial ray pointing in the positive x direction. Its terminal ray, the other part of the angle, points somewhere else. Now, remember, an angle is a measurement of rotation, and rotation always goes from the initial ray to the terminal ray. Now, I could rotate this ray in 2 directions. I could rotate it counterclockwise, which strangely enough is a positive rotation. This one happens to be a positive rotation of 120 degrees. Or I could rotate it clockwise, which turns out to be a negative rotation. In this case, if that positive rotation is 120, the negative rotation is negative 240. All right, so positive rotations are when I rotate the initial ray counterclockwise to get to the terminal ray, and negative rotations are clockwise. We can also talk about coterminal angles, and coterminal angles are just 2 different angles that terminate at the same terminal ray. So these 2 angles are coterminal. But don't get me wrong, those aren't the only 2. In fact, let me go back to my green. If I took this initial ray and I rotated it, and I said, yeah, I don't think I want to really stop there, and I kept rotating it and rotating it and rotating it until it finally landed back here, now that would be a 360-degree rotation plus another 120, so that would be 480. That would also be a coterminal angle with these. Finally, there's something known as a reference angle, and this is amazingly important. The reference angle is always between 0 and 90, and it's always between the terminal ray and the x-axis. So in here, the reference angle is 60 degrees. And I know that, by the way, because the entire straight angle here is 180, and then I just have to subtract 120 from it to get the 60. All right? So all of this terminology is important, but the good news is what we're going to be doing for the rest of this lesson is just getting some practice with it. All right? So pause the video now, write down anything you need to, and then we'll start to get practice with the terminology. All right, let me get rid of it. So, exercise number 1. Very often angles, by the way, in higher level math are denoted or shown with Greek letters. I don't know why. Back in geometry, it's all about capital letters, angle A, angle B, angle C. At this level, we start to go with Greek letters. This is the Greek letter theta, and it's probably the most often occurring. But anyway, it says for each of the following angles given by the Greek letter theta, draw a rotation diagram and identify the quadrant its terminal, this should say its terminal ray lies in, or falls in. All right, so let's draw a rotation diagram. All right, sometimes in rotation diagrams, the initial ray isn't even shown. And the reason for that is that the initial ray always looks like that. Now, if I rotated it 145 degrees, it would have to land in here. Now, think about why that is. A quarter of a rotation is 90 degrees. 1/2 rotation is 180. So a 145-degree rotation must land right there. And that is quadrant 2, right? 1, 2, 3, 4. So it lands in quadrant 2. All right, let's do 320 together. I'm not going to draw the terminal ray, the initial ray, but again, 0, 90, 180, 270, and 360. Those are important. 0, 90, 180, 270. This is assuming we're going counterclockwise, and 360. So 320 would look something like that. And then we throw in our little rotation like that, and we're in quadrant 4. Now 72 is actually so easy it's almost trivial because it's between 0 and 90. So that's the entire rotation diagram, and therefore we're in quadrant 1. Now, as we continue to go, we're going to start to see some negative angles, things like that. An angle of negative 210, let's think about this for a minute. Now we have to be going clockwise. Well, if we go clockwise, this would be a negative 90-degree angle. This would be negative 180 degrees. This would be negative 270. And this would be negative 360. So negative 210 would have to rotate past negative 180, and it would look something like that. And that's quadrant 2 again. All right. Now letter E is pretty easy. Try to draw a diagram for letter E, and tell me what quadrant it's in. All right. Well, hopefully you got quadrant 3, because 250 is bigger than 90, but smaller than 270. So a 250-degree rotation, positive, so it's got to be counterclockwise, is something like that. And that's quadrant 3. Negative 310. Why don't you try that one? Pause the video now. All right. Take a look. Right. Now again, this would be negative 90, negative 180, negative 270, negative 360, right? We have the diagram up here. Negative 310 would have to lie somewhere in between those. Now the actual rotation diagram kind of looks like that, and therefore quadrant 1. All right, theta equals 460. Think about this a little bit. Pause the video and think about what quadrant that would lie in. All right, well, you might have to do some math on your calculator or in your head, but 460 is more than 360. So if we were actually thinking about this, we would start to rotate around. By the time we got to here, that would be a full 360. And now I have to go, let's see, 460 minus 360. I have to go an extra 100. And therefore, we'd end up something like that, and that would be in quadrant 2. Negative 400, maybe the most challenging one we have here. Pause the video, see if you can figure that one out. All right, well, same idea. A negative 360 would be a full rotation clockwise. So that's negative 360 degrees. But we have another negative 40 to go, right? We have another negative 40 to go an entire negative 400. So we must be in quadrant 4. All right. Very important to understand that angles can be anything. They can be positive, they can be negative. They can be bigger than 180, bigger than 360. They can be huge, they can be tiny. And we can locate where their terminal ray lies. All right, pause the video and write down anything you need to. Okay, let me zap it out. Let's see what else we have. Exercise 2. In which quadrant would the terminal ray of an angle drawn in standard position fall if the angle measures 860 degrees? All right, play around with this one. See if you can get the right answer. All right. Well, because 860 is bigger than 360, we go around more than once. So what a lot of students will do is they'll start to subtract off 360 until they get to an angle between 0 and 360. So if I subtract off 360, I'm at 500, but 500 is still greater than 360. So if I subtract that again, what I'll now get is 140. Now 140 will be coterminal, and it will end up looking something like this. Now again, this is the idea. 360, another 360, and then a 140, right? And that ends up being in quadrant 2. All right? Okay, pause the video now and think about this a bit. Okay, let's clear it out. And let's keep going with the terminology. Exercise 3. Give a negative angle that is coterminal with each of the following positive angles. This time I'm going to use the letter alpha. Okay, the Greek letter alpha, first letter of the alphabet in the Greek alphabet. That's why our alphabet's called an alphabet. So let's take a look. So I want a negative angle that is coterminal with this positive angle. Well, positive 90 is here. Now there's many negative angles that are coterminal with it, but the simplest one is like this, and that will be a rotation of negative 270, right? Negative 90, negative 180, negative 270. All right, let's do one more together and then have you do the other couple on your own. 330, well, 330 is bigger than 270 and less than 360. So 330 must look something like this, right? This is a 330 degree counterclockwise rotation. But that means this thing has to be the simplest negative rotation. So you could always just do a little bit of this, 360 minus 330, 30 degrees, but then the answer would be negative 30 degrees because we're rotating clockwise. All right, why don't you try letter C and letter D? All right. Again, I bet that many of you can start to do this without the diagrams, but I tell you we're going to draw a lot of these, so why not? There's 120 degrees. Here would be the clockwise rotation, and a lot of people will just do this. They'll do 360 minus 120, gives me 240 degrees, but since it's clockwise, I'll write negative 240. Finally, a 210 degree angle, bigger than 180, less than 270, so that puts it in our third quadrant. Right? This is 210 degrees. If I want this one, I might do 360 minus 210, gives me 150. So negative 150. All right, not that bad. Right? Again, these aren't the same angles. I want to be very, very clear about that. Coterminal angles, yeah, if you will, they make you end up in the same place, but they're not the same angle, right? And the reason for that is that angles measure two things. They measure how far you rotate and what direction you rotate in. Saying that I rotate 90 degrees versus negative 270 degrees, sure, they may end up so that I'm pointed in the same direction, but they're different rotations. One of them is a quarter turn counterclockwise. One of them is 3/4 of a turn clockwise. And those are different. Ask anybody who does competitive snowboarding or skateboarding. A 3/4 turn and a 1/4 turn aren't the same thing. All right. Pause the video now, write down anything you need to. Okay, let's clear out that text. Keep going, get more work with this terminology. Exercise 4. Coterminal angles drawn in standard position will always have measures that differ by an integer multiple of what? Think about this. All right. Well, hopefully you realize that it has to be a multiple of 360. Right? The idea is very simple. Okay? If I've got some angle, okay, and I want another angle that's coterminal with it, all I have to do is either add 360 or I need to subtract 360. Or I need to do that repeatedly. So if I add two 360s, I'll end up coterminal. Three 360s, I'll end up coterminal. Or if I subtract a 360 or two 360s. Because by adding or subtracting 360 degrees to any angle, you're basically just doing another full rotation and bringing you right back to that terminal ray. Right? Whether you add or subtract 360 makes no difference in terms of the coterminal angle. All right, pause the video now and think about that a bit. All right, let me clear out the text. Let's take a look at exercise 5, last one. It says for each of the following angles, beta, the second letter in the Greek alphabet, draw a rotation diagram, then state beta's reference angle. So we'll review what a reference angle is immediately in the first problem. So beta equals 160, right? That's going to be in the second quadrant, and it's going to look something like that, 160 degrees. Now this is absolutely critical. I'm going to do all my reference angles in red. The reference angle is always an angle from 0 to 90 degrees, no negatives, 0 to 90, okay, between the terminal ray and the closest x-axis. So it's very easy, right? We do 180 degrees minus 160 degrees, and we find that our reference angle is 20 degrees. All right? Let's do one more of these together and then have you work on the rest of them on your own, because these are pretty easy. 300 degrees, that's going to be in the fourth quadrant because it's bigger than 270, less than 360. Here's my rotation diagram. But my reference angle is now that angle. That's beta reference. And that can now be found by doing 360 degrees minus 300 degrees. In this case, the reference angle is 60. All right. So why don't you take an attempt at all the rest of these, even including the weird ones where you got negatives or angles bigger than 360 or negative angles that are bigger than 360 or negative 360. Why don't you go ahead and do that, and then we'll go through each one of them. All right. Well, if a lot of this is seeming pretty easy to you, that is great. We want trig to be easy right from the get-go. 210 degrees, that puts us into the third quadrant like this. That's 210. All right. But what I want is I want this angle. Never the angle between the ray and the y-axis. I want that angle. We can find that angle by doing 210 minus 180. And we find that our reference angle is 30 degrees. Now, letter D might be the one that's the most confusing, right? Here I've got beta reference equals 78 degrees. But if I wanted the reference angle, I would find the angle between this ray and the closest x-axis. And that's also 78 degrees. So the reference angle for an angle between 0 and 90 is just the angle. It's a little bit silly in that respect. You don't really need to know that so much. Let's take a look at 110 when it's negative. All right. So that means I've got to rotate clockwise, and it's going to be somewhere in the third quadrant because it's bigger than negative 90 but less than negative 180, if you know what I mean in terms of size. But my reference angle is going to be right here. And we can now find that by doing 180 minus 110 and getting 70 degrees. That's the angle right in here. All right, let's do negative 280. I really have to learn how to draw these a little bit smaller. Let's see, negative 280 is all just into the first quadrant. Now think about that, right, for a second. Just into the first quadrant because this would be negative 90, this would be negative 180, this would be negative 270, and this would be negative 360, right? My reference angle, whoops, not in green, my reference angle in red is going to be this. Now again, easily done by just doing 360 minus 280 gives me a reference angle of 80 degrees. All right. Now the 605, that's challenging because 605 is greater than 360. So one thing that's helpful to do is to find a coterminal angle that's within what we want. So if I take my 605 and I subtract 360, I'll find 245 degrees. All right, these two things are then coterminal, so they'll have the same reference angle. Let me draw that in blue. No room for my head. That ray is going to be down here in the third quadrant. This is going to be 245 degrees. And now if I want the reference angle, which again, let me draw that in red, I'll just do 245 minus 180 gives me 65 degrees as its reference angle. Now the negative 410, that's going to be a little bit tricky, right? It's bigger than negative 360. A lot of students will do this. They'll take 410 and they'll subtract 360 and they'll get 50. Now what does that really mean? Well, I don't want to do that in red. I've been doing all the rest of them in blue. Okay, let's think about this for a second. What that means is that I'm going around and I've done negative 360. Then I go an extra negative 50. Right, something like that. The cool thing is the reference angle in this case is just that 50 degrees. All right, and that's it. That's reference angles. All right, pause the video now, think about this a little bit, and then we'll wrap up the lesson. Okay, let me clear out the text. All right, so today we dealt with a lot of angle terminology. Angles drawn in standard position, what makes a rotation positive, what makes a rotation negative, angles whose terminal rays end up in the same place, right? And reference angles. Right? So all of these things are going to become important as this unit goes on. It's going to be all about angles, rotations, the geometry of the circle, etc. So make sure that you master the terminology early on in the unit, otherwise it'll just make the harder math more confusing. All right, well thank you for joining me for another Common Core Algebra 2 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.